Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. For this self-quiz, I'm going to give you 12 problems to try, and it's all about factoring in different forms. Now, these first four I want you to try are factoring out the greatest common factor of each expression. So it's one factoring. And numbers 5 and 6 down at the bottom there factor completely, so those are binomials that are being multiplied. All right, so give it a try. Hit pause on this video, and then I'll show you the answers, and we'll talk about it as we need it. All right, let's see how you did. In this first one, as you can see, the GCF is 9x. So you can take a 9 and an x out of each factor. Notice how the first term there would be -4. All right, and when you divide 9x by 9x squared, it leaves you with a 1x or an x. Number 2 is 9, greatest common factor there on the outside, leaving inside 3n plus 1. Number 3, the only common factor is a 2, so you can divide each number by 2 and get 3x plus 4. And finally, number 4 in this group is 10, the greatest common factor. Notice how there is not an a term here on the 90, so you can't also take a 9, or can't take an a factor out of that. Now at the bottom, we have n plus 6 and n plus 7. Notice how 6 times 7 is 42, your third term there. You multiply the 6 and the n, that'll be 6n. You multiply the n times the 7, which would be 7n. You're going to add those together to give you your middle term. All right? So a little bit of a trial and error there, or the factor box method that I showed in one of my other videos. Here, the only common factor is a b. b times b plus 3. All right, back to some more. For 7 through 10, again on paper, I want you to try these first. These are going to be two binomials multiplied together. All right, you might have to factor out a GCF, for example, in number 7 here. And watch out for numbers 9 and 10. Okay, what I've got in there are those two special cases that I talked about in a previous video. 11 and 12 are factoring by grouping, so hopefully you've seen my video about that. All right, good luck. Here we go. Now the first thing we got to do here is factor out a 4. All right. Now if you do that, and that's why that 4 is on the outside there, if you divide each of these by 4, you're going to get 7n squared plus 45n minus 28. Okay, then you're going to have to factor the rest. So here I have 7n times n. That'll give you your 7n squared. I have a -4 times a positive 7. That's the -28. And then we have some combination here to get my middle term. So -4n and 49n. Okay, notice how it's a -4 and a positive 49, so that gives you your 45n middle term. Again, factor out the 4 first as a GCF. Here, nothing to factor out first of all, so it's going to be these two binomials. And again, look at your middle terms. You got a positive 4r and a negative 49r. Okay, that gives you your middle term there of negative 45r. A little bit of trial and error necessary on that one. All right, this is called a difference of two perfect squares. Okay, that's a special pattern we looked at before. Notice how you take the square root of the first term. It's 5b in both places. Take the square root of the last term. That would be a 2 in both places. And because the middle term is gone, that means we have a plus-minus pattern. All right, typical for factoring out difference of squares. This is a perfect square trinomial, which means that the first term is a perfect square, 3n times 3n, and the last term is a perfect square, 1 times 1. Now, it's the key here, of course, is the middle term. Is the middle term the right kind of pattern? Well, we get the 6n middle term from 3n and another 3n. All right, so it does fit the pattern of being a perfect square trinomial, and this is its shortcut exponent form factored. Finally, number 11 and 12. This first group comes from factoring a 5v squared out of those two terms, and that's the expression we get. The second group here can be common factor is 8. So when I factor those out, notice how I have a common binomial, 6v plus 1. All right, so it's that binomial, 6v plus 1, times the two parts that I have right here. All right, factoring by grouping, it's tricky, but after a while, you'll see a very consistent pattern. Again, I look at these two terms, make sure all the exponents are in order there in declining degrees, and I factor out an x squared out of each of those terms, and that gives me these two right here. Notice how 36x minus 42 can be factored this way. 6 is a common factor. All right, so there's a common binomial there, 6x minus 7 in each. So therefore we have that as part of my factored group, and the x squared plus 6. The x squared comes from there, and the 6 comes from there. All right, I hope you did really, really well, and congratulations. Thanks for taking this self-quiz. All right, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. All right, study hard and take care.